Hello, I welcome you all. The problem reads, determine the constant speed of the passengers on the amusement park ride if it is observed that the supporting cables are directed at theta equal to 30 degrees from the vertical. Each chair, including its passenger, has a mass of 80 kg. Also, what are the components of force in the N, T, and B directions when the chair exerts on a 50 kg package. Also, what are the components of force in the N, T, and B directions which the chair exerts on a 50 kg passenger during the motion? This problem is coming from the Engineering Mechanics and Dynamics, 14th edition by R.C. Hibbeler. Right, so here we are being asked to determine, in the first case, the constant speed, right, of the passenger on the amusement park ride if it is observed that it is supporting that the cables are directed at theta equal to 30 degrees from the vertical. The mass of the chair and the passenger is 80 kg. And in the other case, we have been asked to determine the components of force in the N, T, and B directions which the chair exerts on the 50 kg passenger during the motion. Right, so let's draw the free body diagram. So I'm going to section this cable somewhere there, and once I do so, then I expect some tension force. We'll have tension there like so, right? We'll have tension like so, and then we are going to have some components. See this angle here, we've been given the angle there with a vertical which is theta equal to 30 degrees, and this angle is in the NB plane, the NB plane or the BN plane. Therefore, this angle also here, this one here is equal to theta, right? Accept? Of course, this angle here is equal to theta. Therefore, we are going to have the following components. Along the B-axis, we'll have a component of T going up like so, right? And we'll have another component along the N going in that direction like so, right? We also have the weight. The weight of this passenger plus the chair going through the centroid. Let's assume that is the centroid like so. So we have W there equal to mg, and this is just equal to in 80 kg, that is the chair plus the person, times the acceleration due to gravity, which is 9.81. Then this one here, it is T, and so is this one here. Therefore, this becomes T cos theta, and this one here becomes T sine theta. Right, and then we do have the kinetic diagram in this direction. In the T direction, we don't have anything. In the B direction, there is also no movement in there, right? So we are not going to have motion along the B, so only in the N. Along the T, the speed is constant, therefore not have anything there. So this is MAN, right? So let's write down the equations So let's start with the B axis so that we find what T is, and once we found T, then we can go along the N axis, but it doesn't matter which one you start with really. So the summation of forces along the B going up being our reference, this is going to be equal to 0. You don't have any motion in that direction, and therefore we have T cos theta, T cos theta minus W equal to 0. And we know that our W here is just equal to 80 by 9.81, and our theta is just equal to 30 degrees. And therefore our T is just equal to W divided by cos theta, which is equal to 80 by 9.81 divided by cos 30. T therefore is just going to be equal to, where is my calculator? This is 80 by 9.81 divided by cos 30. This gives us a 906.21 newtons. So this is our T. So we have 80 times 9.81 divided by cos 30, 906.21. So found the value of T. Then we can go along the N axis. So say summation of forces along the N is just going to be equal to MAN. We are going in that direction, it will be equal to 0. I mean is positive. Our AN is nothing but equal to B squared divided by rho, where rho is just equal to, what is our rho here? Our rho from this point, so we do have this value here 4, so our rho starting from this point here is a 4 plus the component of this, so plus this length here is 6. Seeing this, we have this like this. Okay, so this is 30 here, this length here is 6, and we do have this other length here to the center, so we have this a 4. So we want to find this. Okay, and for us to find this, then this just becomes 6 sine 30, right? Because this 6 sine 30, right? Because we know to say sine 30 is equal to our x divided by 6. Therefore x is just going to be equal to is sine 30. Okay, so this one is 6 sine 30. Okay, so seeing where this component is coming from, let me wrap this. So this component, I can show it here. Let me just show it so that I avoid some questions in the future. So this is the one that we are getting here. Okay, so this one here is 6 sine 30. Okay, so that's the one we found there, and this is just going to be equal to sine 30 is 0.5, so this is just 4 plus 3, which is a 7. Right, so what do we have here? We have T sine theta. Okay, what else? That's it. Is just equal to MA V squared divided by rho. Okay, so let's write down this. Now we do have numbers, but let's make V subject to a formula. So our V squared is just going to be equal to rho is just equal to T, then rho, then sine theta, okay, divided by M. So if we are to take the square root on both sides, we take the square root on both sides like so, and also here like so, and then we have the following. This just becomes our V is just equal to our T is just 906.21 times rho, which is a 7, then sine 30 divided by M, and we M in our case here is just equal to this M incorporates it incorporates mass of the passenger and the chair, which is 80, right? Okay, and everything under the square root like so. So once we calculate that, then we'll find that our V is just going to be equal to this constant speed is equal to 906.21 times 7 times sine 30 divided by 18, then square root of that. So this we get a 6.30 meters per second. Right, so we found our velocity, our speed, which is this one here. So let's go to the next problem, which is to find the components of force in the N, T, and B direction, which the chair exerts on the 50 kg passenger during motion. So I'll use the same passenger. I'll isolate this passenger and draw the free body diagram. So this is the passenger here, and then we have the following coordinates. We have the the N coordinate. This is the N coordinate, and then we have the T coordinate, and then we have the B coordinate. So this is the N or the normal, the T or the tangential, the B or the binomial. Then we do have the weight. Okay, we do have the weight like so, and then we have the normal force. Okay, that's a normal force. This is the normal force from the chair on the passenger, and then we do have theta, right? Great. So this is our normal force, and then this is the weight. This is the weight, which is just equal to mg, and is equal to 59.81. Then this particular force is going to have components. The normal force, it will have components. It will have one component in this direction. We'll have another component in that direction, in the N direction, like this. So this one here, we are calling it n sine theta. This one here, we are calling it n cos theta. Our theta is equal to 30 degrees. Right. So we want to find n in the n, t, and b components while the passenger is in motion. So let's check out n. We try to find n using two ways. We can find it along the b axis as well as along the n axis, because n is only in the b n plane. The normal force is only in the b n plane or n b plane. Okay, so we expect no component along the t axis of n. So let's apply the equations of motions. We'll say summation of forces along the n direction, going in this direction being our reference, and this is equal to MAN. And we know that our AN is the centripetal acceleration, which is just this, like this, where V is equal to 6.30 and rho is equal to 7 meters. So rewriting all this, we do have n sine 30 sine theta equal to mv squared divided by rho, and our n therefore will just be equal to mv squared divided by rho sine theta. Replacing everything in there, we'll have our n equal to we do have m there is equal to, so we know that m is just equal to 50 kg. What else? Yeah, that's about it. So if we replaced everything in there, we have 50 by 6.30 squared divided by 7 sine theta, and theta we said is 30 degrees. Then we'll have our n equal to 50 by 6.30 squared divided by 7 sine 30. So this gives us a 567 newtons. So this is the value of n using this particular equation of motion. Let's try the other one. Summation of forces along the B going up in our reference. This is going to be equal to, we don't have motion along that direction, so this is just 0. So we'll have n cos theta equal to W, which is just mg, and therefore our n will just be equal to mg divided by cos theta. So n will be equal to 50 by 9.81 divided by cos 30. Our n therefore will just be equal to 50 by 9.81 divided by cos 30. So this gives us a 566.38 newtons. So I'm sure maybe you are wondering to say we have two different answers of n, this and this. Ideally, these are supposed to be the same. These are supposed to be, they are supposed to be the same. The difference is mainly due to the round-offs that we did in our calculation. We did round-offs for the tension in the cable. We did round-offs in the speed, and these had their own compounding effects on the final answer. But again, this is not a big deal, right? a difference of just about a Newton is almost negligible considering the forces that we are dealing with. So it's really up to you either to go for this, to go for this, or to go for this. This is what happens when you do round-offs. All right. So for me, I'm going to go for this. I'll go for this. For really no apparent reason, you can go for the other one. So I'll say, therefore, I'll let my n be equal to 566.38 newtons. And then I do have my theta equal to 30 degrees. So using this now, let's get the components, right? I'll start with components along the B. So I'll call this as NB. My NB, let me start with NN. The component along the N axis, this is just equal to, we said, and this is going in this direction. Let me also show the direction. So my N, okay, I'll show you the final answer. My NN, is just going to be equal to N sine theta, right? N sine theta, that's a component of the normal reaction along the N axis. And if we computed this in this direction like so, if we computed this just gives us, plug in those values, 566.38 sine 30. So we'll have a 283.19 newtons. And then let's go along the T. Our T there is just going to be equal to, we don't have, along this direction, this one is just along, this is along the, it is along, N is along the NBX plane or BN plane. So this we can also simply say, this one is as good as N cos 90. So this one becomes N cos 90 degrees, and therefore we know that our NT, which will be in this direction, okay, is just going to be equal to 0 newtons, because the angle between N and that axis is 90 degrees. Okay, this angle here is 90 degrees. All right, and cos 90 is 0. And then we have NB is just going to be equal to N cos theta, and our theta is 30. So our NB, which is just also going up, it's going up, this just becomes a 566.38 cos 30, and this is giving us a 490.5 newtons. All right, I think this is really about it. We have found all the components along the N, T, and B axis. These are the components coming from the normal force, okay? The chair is exerting a normal force on the 50 kg passenger during motion. So I hope the video was helpful. Let me just outline everything that I've done so far. I'll just outline from this end like this. Okay, there we go. Right, so this is really about it. This is really about it. And I hope this particular video was helpful. I hope this particular video was helpful. And if it was, give me a thumbs up, like my video, continue subscribing and liking my channel. Bye bye, and see you in my next screencast.